Okay, in this part of the lesson, we're going to look at just 1 to 2 specific types of functions. First one being y equals absolute value of x. We're going to start again just with making a table of values and graphing. So, if x is 0, y is 0. If x is 1, we say, what's the absolute value of 1? Remember what absolute value is? Distance from 0, we get 1. X is 2, absolute value 2. All right, so it's not too exciting so far. We go the origin, we've got 1, 1, we've got 2, 2. We get an idea, like off to the right, it is just doing this. What about to the left, though? So absolute value of -1, that's 1. Absolute value of -2, that's 2. So off to the left, we would go left 1, up 1, left 2, up 2, and we've got this branch going this way. So often, you see an unusual function like absolute value x, and you might say, I don't know what that graph looks like. Well, there's 2 plans of attack there. One, get to know it. It's the V shape, and it's going to be that V shape consistently. The other thing is make a table of values. So you never can kind of throw in the towel on any function because you can always make a table and find out what the graph looks like. Okay. Now I'm going to leave that one up. We're going to make a table on this other one down below. And we'll try 0 again. 0 plus 3 is 3. Put a 1 in. 1 plus 3 is 4, so it's growing from there. So let me go to the left a little. How about -1? -1 plus 3 is 2. Absolute value is 2. I'm going to continue my table right here. Go to the left a little bit. -2 plus 3 is 1. Absolute value is 1. Now I'm going to start plotting those points. So there's 0, 3, 1, 4, -1, 2. And I'm going to kind of draw the wrong thing for a second here. It's very common for people to just start getting those points and then just say, well, it's a line. Absolute value is never a line. There's going to be a V to it. It's going to make the turn somewhere. So we go -3. Plus 3 is 0. We're about to make the turn because watch, when I put -4 in, -4 plus 3 is -1. Absolute value is 1. And so what happens is we come down to the x-axis, then we make the turn. Now something we're going to look at in a future lesson is what happens when you add or subtract numbers or alter them. This plus 3 inside the absolute value, notice what it did? It shifted the entire graph to the left 3. Now, one other aspect of absolute value is a lot of people think of it as what's known as a piecewise function. Now, the word piecewise, just because there's like 2 distinct pieces to absolute value. I'm going to look at the red graph again, but on the right, we've got that piece. On the left, we've got this piece. And there's an abrupt change in the graph. On the right side, if you were to just extend that red line, I'm going to kind of clear this out so we can start with a little fresh graph here. But if you take that red line that we had for the right piece and you extend it down into the 3rd quadrant, what you have there is you basically just have the graph of the line y equals x. And the one on the left, when you extend that down, that's like the line y equals -x. So one way that we can define absolute value is we can define it in 2 pieces. We can say that it's just x when x is greater than 0, and we can say it's the opposite of x when x is less than 0. And we actually just write it that way. Put a little bracket and we say y equals that. Now you might notice the way I worded it, I have something missing. One says x greater than 0, one says x less than 0. What about x equals 0? Well, we can kind of pick whichever one to include there, and we're going to include the one on the right. So let's look at a true piecewise function then. So we've got f of x equals, and there's 2 rows, and all those rows are conditions to the graph. Now we've already made tables, so I'm going to plot these points a little quicker here. But I'm going to work on the upper piece first. That says when x is less than 2. So if I'm making a table of values, all I do is I can only plug in numbers that are less than 2, like 1. So if I put 1 in, I get -1. If I put 0 in, I get -2. If I put -1 in, I also get -1. And we know that that's a parabola. So we've got 1, -1, 0, -2, -1, -1. And on the left side there, what we're getting is we're getting a parabola that's curving up like this. But notice I'm only graphing part of the parabola. So this second column, I like to think of it as like the condition. It's the place where you graph it. It's not what you graph, it's where you graph it. This is actually what you graph. Second row then, it's a line. I'm going to go a lot quicker on this one. So first of all, I've got the condition that x is greater than or equal to 2. So I'm going to start over here at 2, and I'll plug a 2 in there. When I plug a 2 in, I get 2 times a half is 1. 1 plus 1 is 2. I can also use slope and y-intercept if I want. I'm sorry, that point I just put on was a little bit to the left. So it should be right here. It was 2, comma 2. But I can use slope and y-intercept. So this thing has a y-intercept of 1 and a slope of a half. So you go up 1 over 2, up 1 over 2, up 1 over 2, and we can just graph it like so. Now, on my parabola, I actually have something missing. Okay, so on the line, it goes and it includes the 2. With the parabola, that one says x less than 2. So I have to really plug in. I have to see what happens when I plug in a 2. When I plug a 2 into the parabola, 2 squared is 4, 4 minus 2 is 2. So it goes up to the point 2, 2. Now it technically doesn't include it because it says x less than 2, but the other side of the graph actually picks up right where it leaves off. So we get a funky graph here. Piecewise functions very applicable in real situations because a lot of real situations don't just follow patterns that are perfect lines or perfect parabolas. They might really alter and make abrupt changes.